leave Los Angeles and look up in the night sky, you will see stars. They do exist, I promise. Now, a lot of these stars are just like the sun, and just like the sun, they have planets that orbit them. We call these exoplanets. They're just planets that orbit other stars. And we haven't always known about exoplanets. We found the first ones in 1992, and excuse me. We found the first ones in 1992, and since then we have found thousands of them. In fact, we found so many that we have an idea of the distribution of planets in our galaxy. And we see really interesting classes of planets, and some of them are called hot Jupiters. You can see here. Now, a hot Jupiter is very similar to Jupiter in our own solar system, which is a gas giant. It's a very massive planet that is all atmosphere. It has no surface to stand on. But unlike Jupiter in our solar system, which is far away from the sun and takes 12 years to complete one orbit, these hot Jupiters whip around their star in just 3 to 4 days. That's how close they are. Now, these are extreme planets, and they're pretty rare. We don't find a lot of them. Most of the planets that we find are smaller and further away, and those are really the interesting planets, the ones that perhaps could be habitable, maybe an Earth 2.0 or something like that. Now, as we investigate this distribution of planets, one thing that we have to be able to constrain is evolution. See, everything in our universe evolves. The life of a planet is no more static than yours or mine. And one way that we know that these planets evolve is called mass loss. And that's what I research in my PhD, planetary mass loss, where literally over time, planets become less massive. They lose their atmospheres to outer space. And in physics, when you want to study a theory or a model, what you do is you test it at its limits. You test it at the extremes, and that's where the hot Jupiters come in. You have an extremely massive planet with a lot of atmosphere, extremely close to a star that's blasting it with extreme radiation. And what we see when we study these planets is that in a process called photoevaporation, high energy photons from the star smack the molecules in the gas giant atmosphere, excite them, energize them, cause them to puff up and literally evaporate, escape to space. In some cases, the stellar output is so strong that it literally shapes the escaped atmosphere into a comet-like tail of material that trails the planet. Now, this is really interesting. A Jupiter-sized planet that orbits in 3 days and has a comet tail of material. But overall, of course, what we want to understand is how the stars interact with the planet so that we can get a better idea of how they shape the distribution of planets in our galaxy. Thank you.